let's say we had the equation 3/5 plus 1 over x equals 2/3. Well, it's time to look at how we would solve rational equations. In the old days, we would have fraction plus fraction. We would need a common denominator. That would be 5x. So the top would need to be multiplied by x for the 3/5, and then here for the 1 over x, the top would need to be multiplied by the 5. And we would have 3x plus 5 over 5x equals 2/3, and we have a proportion. Fraction equals fraction. And fraction equals fraction is the only time where we can do something called cross multiply. Cross multiplication can only happen when we have fraction equals fraction. If we don't have that, we can't cross multiply. Some people look at, say, 1/2 times 2/3 and think, oh, we can cross multiply. No, multiplying, you go straight across. The only time you should ever say the words or do cross multiplication, which, by the way, is when we multiply some tops with some bottoms. If we had A over B equals C over D, we cross multiply. And we multiply A times D. We multiply B times C. And we set them equal. It gives us an equation to solve for x. So fraction equals fractions, cross multiply. 3 times 3x plus 5 equals 2 times 5x. Distribute 9x plus 15 equals 10x. Subtract 9x from both sides. $15 equals x. Looking at the original equation, there's only one value we would not be allowed to have, and that would be x equals 0, because the bottoms of fractions can't be equal to 0. Did we get x equals 0? No, so we're good. X equals 15. But there was also a shortcut method. And the shortcut method was a way of getting rid of the fractions. That was multiplying both sides by the LCD. But just like method 2 of the complex fractions, the LCD is itself over 1. Where we have parentheses, we would have to distribute. The 1 then gets multiplied through the bottoms. But every top ends up hit with the LCD. So it's the same effect as just shoving the LCD into the top everywhere. just like method 2 of the complex fractions. So let me clean this up a little bit. Let me write it down again. Problem was 3/5 plus 1 over x equals 2/3. The LCD of everything, 5x and 3 would be 15x. Let's shove that in the top everywhere. 3 times 15x over 5 plus 1 times 15x over x equals 2 times 15x over 3. Well, 15 over 5 is 3 over 1, and here the x cancels, and here 15 over 3 is 5 over 1. So we're left with 3 times 3x plus 15 equals 2 times 5x. This is 9x plus 15 equals 10x. And if I subtract 9x from both sides, 10x minus 9x is just x equals 15. It is the same answer. So just like complex fractions had 2 methods, rational equations have 2 methods. The first is just use addition and subtraction of fraction rules, addition and subtraction of rational expression rules to combine everything as much as you can until you have fraction equals fraction. The second is to shove the LCD into the top everywhere. Three over y plus 4/3 equals -1. The LCD of everything we need the y, we need the 3, so 3y. 3 times 3y, 4 times 3y, -1 times 3y. That's 9y over y plus 12y over 3 minus, or equals, equals minus 3y. The y's cancel. 12 over 3 is 4 over 1. We have 9 plus 4y equals -3y. If I subtract 4y from both sides, I get 9 equals -7y. And if I divide both sides by -7, positive divided by negative is -9/7 equals y. Y equals -9/7. This was the shoving the LCD way. Is that the only way to do it? No, I could have also made both of these fractions over 3y. So 3 times 3 over y times 3. 4 times y over 3 times y to get both of these to be over 3y. 9 plus 4y. 9 plus 4y all over 3y. This all equals -1. Fraction equals number. That's the same as fraction equals fraction. Cross multiply. 1 times 9 plus 4y. -1 times 3y. So 9 plus 4y equals -3y. Subtract 4y from both sides. 9 equals -7y. Divide both sides by -7. Positive divided by negative is negative. -9/7 equals y. Same answer. There was only one value of y we wouldn't have been allowed to have as an answer. That's y equals 0, because again, we cannot have 0 on the bottom of the fraction. The bottom of this fraction is y. Y cannot be 0. Take a look at this one. Here, our method 1, where we would try to get fraction equals fraction, the 3 would have to be multiplied by w plus 1 over w plus 1. Because everything else has a denominator of w plus 1. And when we add and subtract fractions, and therefore add and subtract rational expressions, expressions containing fractions, we can follow the leader. These two were doing it. We got to do it too. Every parent's favorite argument. So this is 3 times w plus 1 minus 6w all over w plus 1 equals 6 all over w plus 1. Distribute 3w plus 3 minus 6w all over w plus 1 equals 6 over w plus 1. 3w minus 6w, negative 3w plus 3 all over w plus 1 equals 6 over w plus 1. We can cancel, or sorry, we can factor this. If we factor out not worth it. Not worth it to factor, because nothing will cancel. So from here, notice that the bottoms of the fractions are the same. They have been since right here. Fraction equals fraction. Fraction equals fraction. But if the bottoms are both the same, that means the tops have to both be the same. Ever since the point where we had the same exact bottom on both sides. We have not needed the denominator. Negative 3w plus 3 equals 6. Subtract 3 from both sides. Negative 3w equals 3. Divide both sides by negative 3. W equals negative 1. But guess what? We'd be wrong if we said W equals negative 1. The reason we'd be wrong is because there is exactly one value that we are not allowed to have. It's the bottom equal to 0. You might say, wait, we didn't get 0. We didn't get 0, but 0 is not the number that's not allowed. If W was 0, 0 plus 1 is 1. W equals 0 is allowed. The entire bottom, W plus 1, that's what can't be equal to 0. Subtract 1 from both sides. W can't be negative 1. And that's what we got. So we have to throw it away. There's no solution here. Or we can say that the solution is the empty set. Or literally an empty set. But we got to do all that work to get there. Same problem. 3 minus 6w over w plus 1 equals 6 over w plus 1. The LCD of everything. So we'll do method 2. The LCD of everything is w plus 1. So 3 times w plus 1, 6w times w plus 1, 6 times w plus 1. W plus 1's cancel, w plus 1's cancel. We have 3 times w plus 1 minus 6w equals 6. 3w plus 3 minus 6w equals 6. Negative 3w plus 3 equals 6. Subtract 3 from both sides. Negative 3w equals 3. Divide both sides by negative 3. W equals negative 1. But we can't have negative 1. Because w plus 1 can't be equal to 0, so w can't be negative 1. So we throw ours out. No solution. It's much quicker with method 2. So from here on out, we're going to exclusively use method 2. Whether we have a complex fraction or whether we have a rational equation. Let's do another like the last problem we did. Five minus 8 over x plus 2 equals 4x over x plus 2. The LCD of everything is x plus 2. So 5 times x plus 2, 8 times x plus 2, 4x times x plus 2. X plus 2's cancel. We're left with 5 times x plus 2 minus 8 equals 4x. 5x plus 10 minus 8 equals 4x. 5x minus 2. No, plus 2. Positive 10 minus 8 is positive 2. Equals 4x. Subtract 5x from both sides. 2 equals negative x. So x equals negative 2. Another thing you could have done is subtract the 4x over 5x minus 4x would give us x plus 2 equals 0. Subtract 2. We get x equals negative 2 that way. By subtracting 4x from both sides. 4x minus 4x gave us 0, but now everything was over here. We had to do one more step. Either way, we get x equals negative 2. Check our answer. Are we allowed to have negative 2? Well, the LCD, I should say, the denominators are the same. So the only value would be whatever makes x plus 2 equal 0. So we can't have that equaling 0. No, x can't be negative 2. We have no solution. The answer is the empty set. However you want to write it. Next, let's take a look at 1 plus 3 over x equals 28 over x squared. The LCD of everything is x squared. So we're going to take that LCD and we're going to times x squared times x squared times x squared. The x squareds cancel there. One of the x's cancel here. We have x squared plus 3x equals 28. The quadratic equation. How do we solve these? Everything on one side, 0 on the other. Factor if we can to solve, otherwise use the quadratic formula. So everything on one side, subtract 28. 0 on the other. Can we factor this? Yes, we need numbers that multiply to negative 28 and add the positive 3. These numbers are negative 7, no, positive 7 and negative 4. So x plus 7, x minus 4 equals 0. That means that x plus 7 equals 0. Or x minus 4 equals 0. X equals negative 7. X equals positive 4. Are we allowed to have these as answers? Well, x can't be 0. X squared can't be 0. All that means is that x can't be 0. We did not get 0. So our answers are okay. Negative 7 and positive 4, both check. Let's do another. Just like this. One plus 6 over x equals 16 over x squared. Again, the LCD is x squared. We are going to take that LCD and multiply it everywhere. Times x squared, times x squared, times x squared. The x squareds cancel there. One of the x's cancels with the x on the bottom here. Nothing cancels there because there's no fraction. We have x squared plus 6x equals 16. It's a quadratic equation. Everything on one side, 0 on the other. Factor if we can and solve, otherwise use the quadratic formula. So subtract the 16 to get everything on one side, 0 on the other. We need numbers that multiply to negative 16 and add to positive 6. This is positive 8 and negative 2. X plus 8, x minus 2. X plus 8 equals 0 means that x is equal to negative 8. X minus 2 equals 0 means x is equal to positive 2. Both of those answers are okay because x squared not being equal to 0 means x not being equal to 0. And that was our other denominator. We did not get 0. So both of our answers are good. Let's kick it up a notch. And do one more, but a little bit more difficult. (36) over p squared minus 9 equals 2p over p plus 3 minus 1. Whenever we're given something that has anything that factors, we go ahead and start by factoring where we can. P squared minus 9 is p plus 3 times p minus 3. Nothing else factors. But factoring first helps us with two things. It helps us find factors of the bottom that we know can't be equal to 0. So p plus 3 equals 0 isn't allowed. That means p can't be negative 3. P minus 3 isn't allowed. That means p can't be positive 3. P plus 3 isn't allowed. We already did that. It also helps us find the LCD of everything. The LCD is every unique factor to the highest power shown. P plus 3, P minus 3. We already have the P plus 3. So what do we do with our LCD? We put it in the top everywhere. So times P plus 3 times P minus 3 times P plus 3 times P minus 3 times p plus 3, p minus 3. Get rid of this. We remember p can't be 3 or negative 3. There we go. P plus 3's cancel. P minus 3's cancel. P plus 3's cancel. We have 36 equals 2p times p minus 3 minus 1 times the LCD. So minus the entire whatever p plus 3 times p minus 3 is. Distribute the 2p, FOIL these, or use the special formula. So 36 equals 2p times p, 2p squared. 2p times negative 3, negative 6p, minus the entire p squared minus 9. So 36 equals 2p squared minus 6p minus p squared plus 9. 2p squared minus p squared is p squared minus 6p plus 9. Everything on one side, 0 on the other. So subtract 36. 9 minus 36 is the opposite of 36 minus 9. So we're going to end up at negative 27. I need numbers that multiply to negative 27, that add to negative 6. These numbers are negative 9 and positive 3. P minus 9, P plus 3. Which means I get answers of 0 equals p minus 9 gives me p equals positive 9. 0 equals p plus 3 gives me p equals negative 3. One of these is not allowed. We weren't allowed the negative 3. So the answer and only answer is p equals positive 9. Next up, let's take a look at 6 over x plus 2 minus 20x over x squared minus x minus 6 equals x over x plus 2. Factor anywhere we see that we can, and we can right there. Nothing else changes. But here we'll need numbers that multiply to negative 6 and add to negative 1. This is going to be minus 3 and plus 2. X minus 3, x plus 2. Why? Because this helps us see that our LCD has to have an x plus 2, has to have an x minus 3, already has the x plus 2, already has the x plus 2. Oops, let me move this over. so we can see it. There we go. What do we do with our LCD? Hopefully this repetition is paying off, and you know we just shove them in the top. X plus 2, x minus 3. X plus 2, x minus 3. X plus 2, x minus 3. X plus 2's cancel. They both cancel. And the x plus 2's cancel. Leaves us with 6 times x minus 3 minus 20x equals x times x minus 3. Distribute 6x minus 18 minus 20x equals x squared minus 3x. Combine like terms, 6x minus 20x, negative 14x, minus 18 equals x squared minus 3x. Let's get everything on one side, 0 on the other. So we're going to add the 14x over, negative 3x plus 14x is plus 11x. Add the 18 over, plus 18. We're going to factor again. We need numbers that multiply, this time to positive 18. And add to positive 11. This is plus 9 and plus 2. X plus 9. X plus 2. So we get x equals negative 9. We get x equals negative 2. But our factored forms on the bottom told us that we cannot have, x cannot be positive 3, and x cannot be negative 2. So x cannot be negative 2. X can only be negative 9. I want to talk about something called a literal equation. And a literal equation is one that has variables, but they aren't variables. They're actually constants. What do I mean by that? Let's say we had v equals m times little v over little m plus big M. This has 4 variables, not 2. There's a difference between little m and big M. There's a difference between big V and little v. Those are 4 different things. Now, maybe some of these values are known. If they are, then instead of variables, they're actually constants, and we treat them like constants. We treat them like regular numbers. How do we know what do we treat like a number and what do we solve for? Well, we'll be told this one, let's solve it for little m. So we want to solve for little m, but that's there twice. We need to work with this until we get little m equals something else. What we know we can do is get rid of fractions by multiplying by the LCD. Here, the LCD is little m plus big M. If we multiply both sides by little m plus big M, we get v times little m plus big M equals little m, little v. Why? Because the m plus m canceled on this side. How is this helping us get one single little m? Well, patience. Now we're going to distribute. There we go. We're going to distribute to get rid of the parentheses. Big V little m plus big V big M equals little m little v. Now we're going to move terms around so that everything with a little m is on one side, everything else is on the other. Okay, I'm going to go ahead then and subtract big V little m from both sides. I'll get big V big M equals little m little v minus big V m. The gibberish that is probably what you're seeing. This is the key to the problem. Okay, so we got rid of the fractions. We got rid of the parentheses. We got everything with a little m on one side, everything else on the other. That means that we're now going to be able to factor out a little m. We're left with little v minus big V. That's not zero because these are two different things. Little v and big V are not the same. We can't make that zero. But now that we have big VM equals little m times little v minus big V, we can divide by this leftover piece. Divide by little v minus big V on both sides. And what do we have? We have big V big M over little v minus big V equals little m. We have solved for little m. Now, let's do this with something else. Let's say we have y equals ax plus b over x plus d. Let's solve for x. We want to get the x by itself, but there's two of them right now. Let's follow the same steps we did in the last one. First, multiply both sides by x plus d to get rid of the fraction. The x plus d would cancel away on the right. It's multiplied on the left. Distribute to get rid of the parentheses. Now let's subtract the ax from both sides. To move that over here, xy minus ax plus dy is just going to be b. And then let's get rid of this dy because there's no x there. That leaves us with xy minus ax equals b minus dy. Factor out that x. We're left with y minus a. Divide by y minus a. We get x equals b minus dy over y minus a. One over r equals 1 over r sub 1 plus 1 over r sub 2 Let's solve this for r. Now you might be thinking, hey, this is 1 over r. I can flip this to get r over 1. So I can just flip these too. No. Because there's two separate fractions, you cannot flip them both. But if we can get fraction equals fraction, then we can flip it. But it can't flip when it's fraction equals fraction plus fraction. So let's add these together. This would be a common denominator of R1, R2. Which means this needs to be multiplied by the R2 because that's new. What we had times 1. And we had the 1 over r squared, so it needs to be multiplied by, or sorry, R2. So it needs to be multiplied by R1 over R1. What we had times 1. So we have 1 over r equals, this is R2 plus R1 over R1 times R2. Now that it's fraction over fraction, we can flip them both. R over 1 equals R1, R2 over R2 plus R1. So R is just R over 1. We're done. I'm going to write it R1 plus R2. Can add the two numbers in any order, so it doesn't matter. Let's do this same problem again. This time, instead of getting fancy with it, let's do it the way we've done all of them. Because the way we've done all of them is going to work. The LCD would be R times R1 times R2. These are three different things. What do we do with the LCD when we find it? We're going to put them in the top everywhere. So R, R1, R2 over R equals R, R1, R2 over R1 plus R, R1, R2 over R2. Things cancel. The R's, the R1s, the R2s. We get R1, R2 equals R2 plus R1. We're solving for R. We already have all the R terms on one side, everything else on the other. Yay. Factor out an R, R2 plus R1. Divide both sides by what's left, by the R2 plus R1. And there it is. We're left with the R on one side, and it's equal to the R1 times R2 over R1 plus R2. R2 plus R1, order doesn't matter. So let's keep using our method. Let's do another. Let's step out of literal equations for a second. And let's look at 8t to the negative 1 plus 2 equals 3t to the negative 1. Why is this a rational equation? Well, because even though we don't see them, there are fractions here. This is 8 over t plus 2 equals 3 over t. The LCD is just t. So put it in the top everywhere. 8 times t, 2 times t, 3 times t. Things cancel. The t's in both of those spaces. We're left with 8 plus 2t equals 3. Subtract 8 from both sides. 2t equals negative 5. Divide both sides by 2. T equals negative 5 halves. Next up, let's take a look at 5 over x squared minus 7x plus 12 equals 2 over x minus 3 plus 5 over x minus 4. What's the LCD going to be? Well, in order to get that, we need to factor everywhere we can. That's right here. We need numbers that multiply to 12. And add to negative 7. These are negative 3 and negative 4, which means this factors to x minus 3 times x minus 4. Which means that the LCD is x minus 3 times x minus 4. Because we already have the x minus 3 and we already have the x minus 4. I want to clarify one more time that having another x minus 3 doesn't make it squared for the LCD. The only thing that's going to make a factor squared in the LCD as having it squared as the actual factor. And if we have the factor itself and a squared, the squared is what makes it in. It's always each unique factor to the highest power shown. What do we do once we have the LCD? We shove it in the top. X minus 3 times x minus 4. X minus 3 times x minus 4. X minus 3 times x minus 4. And what happens? Things cancel. Both the x minus 3s, the x minus 4s. We're left with 5 equals 2 times x minus 4 plus 5 times x minus 3. Distribute, distribute. Combine like terms. 2x plus 5x is 7x. Negative 8 minus 15. It's minus 23. From 5 equals 7x minus 23, we add 23 to both sides. 28 equals 7x. Divide both sides by 7. X equals 4. But we have to throw that answer away because the x minus 3 and the x minus 4 on the bottom mean that x can't be 3 and x can't be 4. So we have no solution. Four over x squared plus 7x plus 12 minus 7 over x squared plus 8x plus 15 equals 1 over x squared plus 9x plus 20. All three denominators can factor. Numbers that multiply to positive 12 and add to positive 7. That's plus 3 and plus 4. This one factors to x plus 3, x plus 4. Minus. Here we would need numbers that multiply to positive 15 and add to positive 8. These are plus 3 and plus 5. So this factors to x plus 3, x plus 5. And here we need numbers that multiply to positive 20 and add to positive 9. These are plus 5 and plus 4. This factors to x plus 5 times x plus 4. So what are our restricted values? What are the values we can't have? Well, x plus 3 on the bottom means x can't be negative 3. X plus 4 on the bottom means x can't be negative 4. We already did the x plus 3. X plus 5 on the bottom means x can't equal negative 5. We already did the plus 5. We already did the plus 4. That's the same process we're going to do to find the LCD. Instead of solving for equal to 0, though, we take each unique factor. So what is the LCD? X plus 3, X plus 4. We already have an X plus 3, X plus 5. What do we do with the LCD when we find it? Put it in the top everywhere. X plus 3, X plus 4, X plus 5. X plus 3, X plus 4, X plus 5. X plus 3, X plus 4, X plus 5. Things cancel. The X plus 3 and the X plus 4. The X plus 3 and the X plus 5. The X plus 5 and the X plus 4. Which leaves us with 4 times X plus 5 minus 7 times X plus 4 equals 1 times X plus 3 is just X plus 3. I'm going to give myself more room. Keep my restrictions so I can see them. I'm going to move this up. I'm going to finish the problem. Distribute the 4. 4x plus 20. Distribute the negative 7. Negative 7x minus 28 equals x plus 3. 4x minus 7x is negative 3x. Positive 20 minus 28 is negative 8 equals x plus 3. Add the 3x to both sides to move it over to the right. Negative 8 equals 4x plus 3. I'm going to subtract 3 from both sides. Negative 11 equals 4x. I'm going to divide both sides by 4, giving me x equals negative 11/4, which is not negative 3, which is not negative 4, which is not negative 5. So it is the answer.